Take your right arm and flex it. Now look at your bicep. Haven't you ever wondered how muscle contraction is possible? Well, it works by this thing called the sliding filament theory. But before we go into that, we have to learn a bit of vocab. First off, ADP plus phosphate, an important organic compound in metabolism and is essential to the flow of energy in living cells. Calcium makes up your bones. ADP, ATP, energy, myosin, thick, and actin, thin. They both have the same definition, and it's a protein that forms in contractile filaments of muscle cells. Tropomyosin, related to myosin and occurs together with troponin in the thin filaments of muscle tissue. Troponin, a globular protein complex involved in muscle contraction. Now that you know the vocab, let's get into the steps. Step 1. Action potential from somatic nerve stimulates muscle fibers at neuromuscular junction. Step 2. Action potential causes the opening of potassium channels on the sarcolamella, which causes a wave of depolarization to travel from the neuromuscular junction. Step 3. Depolarization event is communicated deep into the sarcoplasm. Step 4. Depolarization of sarcoplasmic reticulum causes an opening of calcium channels and the subsequent release of calcium from the sarcoplasmic recticium. Step 5. Calcium binds to troponin. Troponin molecules change shape, causing tropomyosin to move off the cross bridge of binding sites on actin. Step 6. Myosin hooks on the binding sites on actin. Step 7. ATP acts on the binding sites on the myosin to convert it into ADP plus phosphate energy. Step 8. Released energy causes a power stroke, which causes actin to slide over myosin. Step 9. Sarcolemma repolarizes due to an opening of potassium channels. Step 10. Calcium channels close and active transport pump carries calcium back to sarcoplasmic reticulum. Step 11. Troponin returns to pre-calcium shape and ATP reforms to release the actin-myosin bond. Thank you. That's it.